let's go back here. Graph an ordered pair. The question we're going to seek to answer by the end of this lesson is, how can I display equivalent ratios on a coordinate plane or a graph? Sometimes we call a coordinate plane a graph. It's just the fancier term for graph. So right now I'm going to zoom in to the top half of the page. It will be a good time to pause it while you copy. Then I will scroll down to the bottom half of the page so you can copy that. And now for the bottom half of the page. Oops. Okie dokie, welcome back. Hopefully you didn't have too much trouble drawing that coordinate plane at the bottom of your page. If you did, I have, as you know, a stack of blank coordinate planes, squares, that you can paste into your notebooks to make that a little easier for you. But let's jump right into the lesson. Looking at the top half. We looked at our question already. How can I display equations on a coordinate, or sorry, not equations. How can I display equivalent ratios on a coordinate plane or a graph? It's pretty simple, actually. The task is to just turn your ratio into an ordered pair. Ordered pair is x, comma, y, and plot the points on the graph. If you remember, like a week or so ago, and every class since then, I've reminded you that when we are looking at a ratio, let's just make one up, 5, oh, that's kind of big. Let's make that a little smaller. Like, for instance, we have 5 to 4. We could think of our first number as being our x value and our second number as being our y. So another way you could write that, if we were going to graph it, would be 5, comma, 4. Alrighty? Hopefully you remember from back in elementary school how to graph ordered pairs, x, y, on a coordinate plane. If not, I'll give you a quick refresher. It's really not too bad. In order to review how to graph points, how to, like we wrote here, how to plot points on the graph, let's start with a fresh graph. So here we have a fresh graph. First off, let's label it. Like we said a moment ago, in our ratio of 5 to 4, if we consider this an ordered pair to graph, we'd call it 5, comma 4, right? Our 5 would be our x value, and our 4 would be our y value. So over here on the graph, we are looking at a vertical line, and a horizontal line. Our horizontal line is our x-axis. Our vertical line is our y-axis. Axis is A-X-I-S. Hopefully this at least rings a bell from previously in your life. Now down here at the base, we're going to say that this is 0 on the x-axis and 0 on the y-axis. Let's assume that each line just counts by 1. So we start with 1, 2, 3, 4, 5. What you would do if you are plotting these points, 5, comma 4, you would count 5 over on the x-axis. Start at 0. We got 1, 2, 3, 4, 5. Follow this up. And then you would count, let me get rid of those little dots. Then you would count 4 lines up on the y-axis. So you would go 1, 2, 3, 4. Or an easier way to do that might be to do it over here. 1, 2, 3, 4. So if we wanted to plot the point 5, comma 4, it would go right here. That's how you plot a point. All you have to do, if we're talking about ratios is come back over, turn your ratios into ordered pairs. You see that we've done that in our chart or our ratio table here. If you're looking at this ratio table, our first ratio starts with 2 to 0. So that's 2 games for every 100, or every 2 games there's 100 yards. Let's just say that this is David Johnson, the Arizona Cardinals running back. This is not a very good ratio if this is a true running back. But let's say for every 2 games, he runs 100 yards. So if you count down on your table here, every 4 games, he would run 200 yards. Every 6 games, he would run 300 yards, and so on and so on and so on. Hopefully you remember that we, in a ratio table, we're only working with equivalent ratios. So these are all equivalent ratios here in our table. Alrighty, now let's plot those. What we've done over here on the side is if we have taken our x value of 2 and made it our x coordinate. We've taken our y value of 100 and made it our y coordinate. And we've done the same thing all the way down the line. Okay, that is this information here. So let's go ahead and graph this stuff. I've already done it, but we'll follow along if you don't mind. We'll take our first value. Well, let's zoom in here a little bit. Maybe we can't. We'll take our first value of 2 to 100, and we will count over 2. We've got 1, 2, and on our y-axis here, I'm counting by 50 every line because I don't want to put 700 lines on this graph. So we've got 2 to 100. All right, that's our first one. 2 to 100 is done. Let's take 4 to 200. So we come over here, 1, 2, to get to the, get rid of that. Come over here to the 4, and we have 200. There's a dot there, so we're good with that one. Let's take 6 to 300. We have 6, and we go all the way up to 300. Alrighty, that one is done. Let's take 8 to 400. Go to our 8 on the x-axis and go all the way up to the 400 on the y-axis. Done. As you can see, we're going on and on and on. The 10 goes to 500 because we have 10 to 500. That one's done. And we have our 12 to 600. So that is done. Graphing them, it really isn't all that challenging. And I'm sorry if it threw you off because I already had the stuff on here. Let me get rid of some of these circles over here. Clean it up some. So the neat thing, that's really all you have to do to graph them. But the neat thing about putting them in a graph is it helps you visualize your information a little bit more. So in this graph, you don't even need to plot the next point to know where the next point is going to be. So if our ratio table extended any further, so let's bring this down. If our ratio table extended, oops, one more line, let's see if the graph will tell us what can go in that chart. So if we're following our line along the line all the way up, it's going at a consistent pace. Let's see where it would cross at the 14 mark. I'll slide up a little bit more so you can see the 14. At the 14 mark, where is the y-axis going to be? Let's follow it all the way up. 14 all the way up, all the way up, all the way up, all the way up. Oh, it crosses right here. Follow that over. We are at our 700 mark. It kind of is hard to tell where this 700 goes, but this, I'll zoom in a little bit. This 700 corresponds to this line right there. So, zoom back out. We want to know where the 14 connects on the y-axis. The 14 connects at the 700 mark. Is that what you would have guessed goes in our box here? 14 and 700. And our coordinates are 14, comma, 700. So anyway, that is how you graph ratios on a coordinate plane. It just takes a little bit of practice to get used to, but really, once you master the graphing portion, it's not too complicated. Be a whole brand new one. Here we go. The x-axis is the bottom line that goes from left to right. The y-axis is the line that goes up and down. Let's say we take that ratio from before, our 5 to 4, which we said is just 5, comma 4. 5 is our x value, and 4 is our y value. So if we want to graph our 5, we come over here, and let's just imagine that each line is we're counting by 1, so this would be 1, 2, 3, 4, and 1, 2, 3, 4. So we'll start at 0. That's 0, 0. Actually, do that in black. That's 0 for the x and 0 for the y column. So we'll take our x value, which is 5, and we'll count 5 over. 1, 2, 3, 4, 5. You don't have to do the squiggly lines on the bottom. Then we'll take our y value, which is 4, and we'll count up. Got 1, 2, 3, 4. And where those two lines meet is right in the middle, right there. Okay? So really what you'll do is you'll go over 5. You'll go over 5, 1, 2, 3, 4, 5, and then up 4. 1, 2, 3, 4. It's that simple. Okay? So let's go back to